chemical bonding. Chemical bonding, there are several different types of chemical bonds, and we're going to talk about how we can distinguish between the different types here. Okay, so the first type that we're going to talk about are we're going to kind of classify these. Okay, the first type is called covalent bonding, and covalent bonding involves a sharing of electrons. So we are sharing electrons between different atoms. Sharing electrons here. So here are some examples of covalent bonding. Ionic bonding, then, which is your next box on your notes, involves the transfer of electrons. So an electron from one atom is going to get transferred and accepted by another one. And when that happens, they end up being charged differently. This is a positive charge. This is then a negative charge because it accepted an extra electron. And it's the attraction of that positive and negative for one another that's going to be able to keep these compounds together. Okay? Then the next type is called metallic, and metallic involves a sea of electrons. So here you're going to have a positive cation, and your electrons are going to be able to flow or move kind of independently through those cations. And that's why these metals are capable of moving electricity, because all electricity is moving electrons. That's all it is. So when you have electricity, you're just moving these electrons, they're flowing through, and that's capable of being done in these metals. So you have these sea of electrons. Okay? All right. If we look more closely at covalent bonding, a covalent bond is going to share electrons. It's going to make what's called an octet. That's why as we moved across the periodic table, we counted 1, 2, 3, 4, 5, 6, 7, 8. Okay. When it has an octet, when it has 8 electrons in its outer shell, then the atom or molecule is going to be stable. The smallest unit of a compound that has the property of that compound is called a molecule. And typically, these are 2 or more nonmetals bonded together. So we're going to have 2 or more nonmetals brought together to form these covalent bonds. Is that making sense? Anybody still need this slide up? All right. Ionic bonds then are going to involve a transfer of electrons. So we're going to be transferring electrons so that we can get that noble gas configuration, so that we can end up with a full octet on the outer ring. We want to have 8 electrons in the outside, and ionic compounds transfer electrons to make that happen. So for example, with this sodium, if I take this electron off, then I'm going to have a full octet here of electrons, and this will be stable then. If chlorine takes one more electron in, then it'll have a full octet and it'll be stable. The smallest unit that has the property of the compound here then is going to be the formula unit. And this typically takes place between a metal and a nonmetal. you should be familiar at this point with where metals and nonmetals are on your periodic table. So remember, if we kind of draw kind of a sample here of our periodic table, okay, we have that stair-step line over here, and I'm not a good drawer, but you get the idea. The stuff over here are going to be your nonmetals and hydrogen. Hydrogen is also a nonmetal. That is my hydrogen. Okay. And then the rest of this is all metals. Remember that from last semester? Okay. All right. Metallic bonding then is going to have this sea of electrons where you have those surrounding your metal ions, and it occurs typically between two different metals. Good? All right. Now, how do we determine our bond types? Typically, we have kind of a sliding scale where we are going to look at something called an electronegativity difference. So when we're looking at electronegativity difference, mathematically, what does this word mean to you, difference? What do you need to do? Subtract, right. So you need to know the electronegativity values for these elements. You will not ever have to memorize these, okay? You will be given a chart if you need one, and you don't have to have them memorized. So breathe, okay? It's going to be okay. You can subtract. You can use a calculator if you need to. All right. So when we are looking, if we have a large difference in electronegativities, then we're typically looking at ionic bonds. The other types of bonds that we're dealing with, if it's not metallic, are going to be covalent bonds. And there's two different types of covalent bonds. There's a polar covalent and a nonpolar covalent. Now, where have you heard something called polar before? Not in chemistry.
Polar.
Polar bear, right. Where do we get the term polar bear from? Like
cold.
Cold, right. So polar bears live at the North Pole, which is the Arctic. Okay, so we have our polar bears up here. This is our North Pole. Down here, which is our Antarctic, we have our South Pole. And what critters are distinct to the South Pole? Penguins, right. Okay, so we have our penguins down there. But these are two opposites. So that's where they come up with the term polar. They will sometimes talk about, political ideologies being polar opposites. Okay, so what that means is that it's two very different things, like a North Pole and a South Pole. When we talk in terms of chemistry, when we're talking about poles, we're talking about a positive and a negative. And the reason why we have positives and negatives is that some of the atoms are kind of electron hogs. And when they share electrons, as in a covalent bond, they don't do it equally. Okay? So it's kind of like mom and dad got a divorce, and mom gets you 5 days of the week and dad gets you 2. Okay? It's not an equal amount of time, right? 5 versus 2. So sometimes with atoms, we could end up with some of them having the electron more than the other side. Okay? This is a chart of electronegativity differences. Again, you do not have to have this memorized. You just need to be able to find two different elements on here and subtract their values. Okay? So, if given this chart, you need to be able to do that. Can you do that? Okay. You can use a calculator if you want, but hopefully you won't need to. All right. I think I gave you a couple examples on there I wanted you to run through. Did I?
Yeah.
Okay. Give me the first one.
Strontium fluoride.
Calcium fluoride, you said?
Strontium.
Oh, strontium. Sorry. Okay. So strontium and fluorine. Okay. So we're going to find those values on here. Strontium is a 1. Fluorine is a 4. So what is their difference? 3. So then you go over to, oops, I went too fast. You go over to this chart and you find 3 here. And 3 tells us that that's going to be an ionic bond. Yep.
What if it's like 1.75?
If it's right on the line, typically we consider ionic is usually greater than 1.7. Polar covalent is 0.5 to 1.7. And then nonpolar covalent is going to be less than, so that would be less than 0.5. I think I got my arrows pointed the right direction. So this is usually kind of the cutoff threshold for those. All right, what was my next one? What? Nitrogen and oxygen. Okay, so nitrogen is 3, oxygen is 3.5. Differences 0.5. Okay, so if it's 0.5 to 1.7, that's going to be polar covalent. And then what was my last one?
I think there's only 2.
Was there only 2? Okay,
Yeah.
I screwed up then. Okay, sorry about that. All right, but you get the idea how to put them on the chart, right? Yep. Mingo? Okay, so I'm going to hand out your homework here real quick.
Oh, wait, can you go back to the differences?